Good afternoon, everyone. Okay, let's just wait for 2 to 3 minutes more. Let's everyone join, then we will start the session, okay? Otherwise, they will miss the new topic. Attachment. Hi, Achal. Actually, not all the recordings I have uploaded. Those who have asked for particular days, I have uploaded those recording and shared with those candidates. So if you need any particular day recording, do let me know. I'll upload that and share that with you.
Ma'am, I need yesterday's recording only.
Okay. Then I'll upload that and then I'll share it with you.
It is already uploaded. Rojitsan
For
and
Rajasthan. Okay.
yes.
Just give me 1 minute. I'll share it with you. Okay.
Okay. Thank you.
कर दिया मैंने शेयर ठीक है
Okay, Akanksha, check it. Sorry, Achal, please check it. I have shared it with you.
Yes, ma'am.
Very few candidates are there today.
Ma'am, I didn't receive it. I mean, like, have you shared on WhatsApp?
It will be on Drive.
I don't
Drive
have the
and
Drive link.
yes, go in Drive and check and share with me folder.
No. I don't have the Drive link itself.
See, it's on your email ID. Just give me a minute. Your email ID is achal.saxena729@gmail.com, right?
Okay. Okay. Yes, ma'am. Got it. Yes, ma'am. Received. Thank you.
Okay, it's already 3:09. Let's just start the session. We cannot wait more for other candidates. Ashish, do you want to say something?
Yeah, I wanted to ask like I'm near to Noida. If I wanted to come to CDAC Noida, so
Yes.
and talk about about projects, so it will be possible. Like
Okay. See, I have to check my timetable. After checking my timetable, I'll let you know at on which day. I think on Monday you can come, but even on Monday, I'll be free by between 12 to 1 I'll be available, and then after 4 p.m. Between means 4 p.m. to 5:30 I'll be available because so what you can do, I'll ask another faculty, okay, if they are available, if they are free at that time, you can come and you can have conversation regarding you can discuss your project with those faculties. Okay.
okay,
My timetable is quite busy right now, but I'll ask another faculty. Okay. So they will guide you regarding that.
okay.
So I'll ask them and I'll let you know if you can come on Monday or not.
Yeah, sure, sure. Thank you.
Yeah. So I hope this random forest ensembling methods are clear to everyone. Bagging and boosting. Okay, individual tree. See, this I have not means I have not plotted this decision tree for random forest, because actually it is not required. Because if you if you are showing in any project or any program, basically when you are dealing with random forest, you show only accuracy. So I have never tried that, but definitely maybe if I'll get time in weekend, I'll try that how we can plot the random forest decision trees. Okay, and then I'll give you the solution for it. Okay.
Okay, ma'am.
Apart from that, I hope bagging and boosting is clear to everyone. And we can start with a new topic today. So I hope that this will be your last topic, and some of you have asked for Spark revision. So after our clustering gets over, you will have your Spark revision session. Okay. See, I'm thinking that the complete instead of means having revision, what we can do is we will provide you the recordings of earlier session. Go through with that, and if you face any difficulty, write down your doubts, and then if after that if we have the revision session, that will be more fruitful. What do you say?
Yes, ma'am.
Works
Yeah,
for.
that will, yeah.
Yes, ma'am.
First go through with the recording, and if it doesn't work and means you have doubts, then we can have revision session. I think that will be more beneficial. So we'll go like that. Okay, so in weekend I'll upload these recordings. Okay, I'll share these recordings with you now, and then you can start. Since once clustering gets over, you can start with your project. I'll tell you who is going to guide you. Okay. So now, same thing I'm repeating again, that you have learned about machine learning algorithm. Okay, supervised, unsupervised, and reinforcement. In supervised, we have classification and we have regression. A classification example you have seen, which is decision tree. Okay, decision tree can solve the regression problem as well. Okay, that is why it is also known as CART algorithm, CART, classification and regression type. Okay, and then we have seen ensembling, which means when you ask the result to not only to one algorithm, you ask the result to more than one algorithm. Okay, you train the model you train your data set on different models on different algorithm, and then you can use that voting method or averaging method to find out the result. That was the last topic that I need to discuss, but uh, I just skipped this clustering because you have some idea of decision tree. Okay. Then in unsupervised, we have two types of algorithm. One is clustering type and another one is association. Association is like if you have bought bread and butter, then it is most probably that you will buy milk. Okay, something like that. If you have to solve problem like this, then you have association type. And clustering, when you group the things together, similar type of items together. Okay, here we are going to discuss basically k-means. K-means is a popular clustering algorithm. Okay, so today this will be our last topic which we are going to discuss in machine learning. There are several algorithms. Okay, you all know if I'll keep on telling every algorithm, our sessions will never get ended. Okay, so what you can do, whatsoever algorithm used in your project, you can study about that Okay, and if you face any difficulty, you can raise your doubts in group or in sessions. Okay, or even if your registration means that online registration get expired or these sessions gets over, still you can ask your query. Okay, it is not like that after this we will not answer your queries. Okay, even our previous students, okay, those interns are still asking their queries, are still doing projects and everything, and we definitely, maybe not immediately, but we definitely answer. So today we are going to study about unsupervised clustering algorithm. Just give me a minute. Clustering is the method of identifying similar groups of data in a data set called clustering. Okay, means if you have a data set, let's suppose of dog and cat. Okay, I always end up with the same example, those animals, cat and dog. Okay, you have the features of these animals. Okay, cat features is there and dog features are there. But you do not have that data set as labeled. Okay, means it is not mentioned after the features, at the end of the feature it is not mentioned that it's a cat, it's a dog. This is not mentioned, the data set is unlabeled. Okay, then what you can do now, still you need to analyze your data. What you can do is you can group the similar type of features together. Okay, so if you will group similar type of features together, you will get a segregation. Okay, one segregation will be of cat, another segregation will be of dog. Still your algorithm will not say that this group is for cat and this group is for dog. Okay, still your algorithm will not answer this question, but what it can do, it can group the similar type of things together. Okay, now it is one of the most popular technique in data science because every time we do not get the labeled data set. Okay, so this is the reason that this algorithm is very popular. Entries in each group are comparatively more similar to entities of that group than those of other group. This statement may sound if you'll first time see, this may sound difficult, but what does this means is, suppose if I have this graph and I'm creating one group over here, similar type of features are here, and here also I have similar type of features. Okay, so the data points means the rows which are present in this group will be very similar to each other and will be dissimilar to this group. If I talk about this group, these the features which are present here will be very different. Will be very different which the features present in this group. Okay, and these will be similar with each other with the data points present in this group. Okay. I hope you got some idea about clustering. We will see its implementation as well, but I hope you have some idea now. You got some idea about this clustering. So this is one of the example. Like we have some features which we have colored in different colors. Okay, and they are somehow making groups. Okay, 3 groups they are making. We will see how we can do that. Okay, how we can create groups. What are the uses of clustering? So you can use it in different problems, like if you want to do market segmentation. Okay, for example, there will be customers who like Western product. Okay, there could be customers who like Indian, these traditional products. Okay, traditional dresses. So you can group them according to their need. Okay, according to their choices. Social network analysis, search result grouping means if you are searching something on Google, you will get a similar type of results. Okay, if you are searching car, you will get the in your result page, you will get similar type of output. Okay, it will not be like you are searching car and you will get output for cow or cat. It will not be like similar type of result you will get. Car models will be there, car prices will be there. Okay, car websites will be there like this. Now, image segmentation. Suppose you have an image. Okay. Let's suppose you have a medical image. Okay. So similar type of cells will be grouped together. Okay. Anomaly detection. Okay, means you have grouped some features together. But there is something which is coming out of the group. Means you have placed some features which were coming in this group only. The data points were here only. Okay, but okay, but there is some data point which is not coming in any group. Maybe there is another group as well, but there could be one data point which is not falling in any of the group. Okay, then that type means anomaly, something out of the window is there. Okay, so that type of things can be find out, like if you are trying to predict cancer. Okay, so there could be cells normally working, but there could be some cells which is not falling in any group. Okay, so that type of anomaly can be found out. Okay. Now, after clustering, each cluster is assigned a number called cluster ID. Okay, this is very beneficial. You'll get to know what is the benefit of assigning cluster ID. Means I have one data set. Now, there are some features mentioned here. Okay. Now, this one row will be known as data point. Okay, data point. This is another data point. This is another data point, and so on. What you do, when you plot a graph, you plot this whole data point. This one data point you have plotted. Okay, then another. Maybe these are falling in one group. Okay, and this is falling in one group only. Okay, like this, and another. Now, another group. Now, what we are doing instead of see what we are doing now, instead of now calling this data point, these data points which we have plotted by these features, whatever features are given. Okay, that it is of red color, like brown color, 2 years, something like that. All those things. Instead of now calling with all those features, we are going to assign these features to one ID. This is cluster one. This is cluster two. Cluster IDs we have given. Now, if I want to call this row, I'll say that it belongs to cluster ID 1. If I want to call this row, I'll say, suppose it also belongs to cluster 1. So I'll say it belongs to cluster ID 1. I'll not call all the features that 2 years, brown eyes, something like that. Okay, not like that. So cluster ID we give. We will soon know that what is the advantage of giving cluster ID. Okay. Now, for example, you can group items by different features as demonstrated in the following. Like you can group stars by brightness or by their size. You can group documents by topic. Like if you'll go to the library, you will see that by the author name or by the subject or by the years, the books are organized, right? They are documented. They are grouped together. They are placed together. Okay. So this is how there you can say that this is clustering, this is grouping. Okay. Now let's see one example that how Google is using clustering, where it is using clustering, how it is getting advantages from clustering. So clustering is used for the generalization purpose, data compression purpose, and privacy preservation. And there are many other things as well where Google using it and getting different advantages from it. Okay. So generalization is this when you have like some example in a cluster having missing features, like you have some data set. Okay. And there is some value which is missing from this row. But looking at the other feature, you are being able to say that these features belongs to cluster ID 1. Okay, if you can say that these features belong to cluster ID 1, then you can fill up this value. Okay, because by taking the other values, by taking the average of other values which present in the same cluster. Or what you can do, you can take the maximum value, average value, or default value of that group from which this row belongs. Okay, so in generalization method you can use, let's suppose you have a playlist in your, means there is some new song. Okay, and you want to make that song popular. So what you can do, to make it generalized, what you can do, you can place that song with a playlist. Okay, with a playlist which is whose rating is good. Okay, who's watched a number of times by users. Okay, by viewers. Okay, which have well, a good number of views. Okay, so what will happen generally, if you in a YouTube, suppose you have opened a playlist. Okay, you are listening a playlist. So if any, means what generally you do, you just click on a playlist, and whatever song is coming, generally it's a habit that you do not just skip that song. Okay, in a playlist, if song is playing, you generally don't skip it. So there are chances that the new song will come into that playlist. User will, or a customer will listen it, view it, and their views will increase. Plus maybe maybe that user started liking that new song. Okay, so that song's popularity can be increased. Okay, so this is how generalization works. Okay, another thing is data compression. Okay. So data compression is like, now if you remember that cluster ID concept, what we were doing in cluster ID, we were giving the whole feature, we were denoting it with a cluster ID 1, that it belongs to cluster ID 1, another cluster ID 2, another row cluster ID 1, another row cluster ID 3. Okay, so we are not calling these rows with individual features or individual values. Okay, we are now calling them by the cluster ID. So now, if you will store this data set, okay, you can say that it belongs to cluster ID 1, cluster ID 2. So the storage, you are being able to save the storage. Plus, if you are giving this data set to a model, okay, if you will give the complete data set, your model will become complex plus slow. Okay, so instead of that, if you will feed the cluster ID, your model will be fast and less complex. So two things you can do here. You can make your process speedy, and you can save the storage if you by clustering, because now instead of referring it by complete features, we are referring it with a cluster ID. Okay, so this is how data compression can be done. Another thing is privacy preservation. Okay, privacy preservation. For example, I am analyzing YouTube history. Okay, let's suppose YouTube is analyzing users' history. Okay, like what type of videos they like to watch. Okay, maybe a educating video, or a song video, or dance video, or maybe DIY videos. Okay, something like that. Okay, maybe some other type of videos. So if they will have the data like user ID, username, user email ID, and what type of videos they have watched, and they want to group these type of users together. Like if someone is watching educational type of videos, they will group those users together. Okay, like this they want to analyze the history. But what will happen in this case? Now users identity will be revealed, because to group the users, they have users email ID, users name, and everything. Their privacy is revealed that they have watched some or the other video. Okay, to avoid that, we will not refer user by their user ID, username. We will refer them with the cluster ID. To every we group the cluster together, we group the people together, and we will refer them with the cluster ID, not with their name or not with their email ID, right? So this is how we can do privacy preservation if we are referring that data with a cluster ID. I hope these points are clear, that how Google is using this clusterization and how it is getting advantages from it. Okay, heart is beneficial. Clear to everyone?
Yes, ma'am.
Okay, good. Now, types of clustering. So broadly, if you are classifying, there will be two types of clustering. Okay, so hard clustering and soft clustering. Hard clustering is when you have a clear cut clusters. Okay, sorry, no, my graph is little. Let me just remove it. This is my graph. Okay, I'm making only two cluster. It doesn't mean you can only make two cluster. You can have more than two cluster. Up to you how many categories you have or how many groups you want. Okay, so now some data points are present here. And these will be of oval shaped. Okay, I am not being able to create this oval shape. This basically will be a circular or a oval shaped clusters will be there. Okay. So now if there is some data point which present into this cluster, okay, means this data point belongs to this cluster only. This will not belongs to this cluster. Okay, there will be zero probability that this data point will belong to this cluster. Means if I name them 1 and 2, okay, so if one data point belongs to cluster 1, so there are zero chances that it will belong to cluster 2. This is the case when we talk about hard cluster. Okay, okay, either it belongs to 1 or either it belongs to 2. It will not be like this data point is belonging to both of the cluster. Okay, but hard soft clustering is there is some probability that there is 0.2 probability that this data point belongs to cluster 1, and let's suppose there is 0.3 probability that that data point belongs to cluster 2. Okay, so like if you are grouping some customer, so there could be some people, like if you are grouping them based on their choices, like traditional or western. Okay, so there could be people who only like traditional, or there could be people who only like Western dresses. Okay, but there could be some people who like both type of things. Okay, maybe 30% they like this traditional, and 20% they like the Western one. Okay, this could be the probability. Okay, so these type of people, now these type of things will fall into the cluster, soft clustering. Okay, in hard clustering we are going to study about k-means. Okay, sorry, I'm not being able to write. I think my mouse is not working correctly, or I'm not being able to write it correctly. Okay. Another thing in soft clustering, we are not going to study about that in detail. We will only see its k-means implementation. If you have interest, you can go with the soft clustering as well. Okay. Now, that was the broader classification. Okay. Now, if you will see that some authors have divided, or you can say in hard clustering. Okay, some authors have divided it further. Okay, not the hard clustering, but some authors have, you can say, has done some broader classification on clustering, which was centroid based, density based, distribution based, and hierarchical based. Okay, if you'll go with some other research people, you will find some others as some other type of clustering as well, but these four were the main ones. Okay, centroid based clustering, the example is k-means only. So hard clustering, you can say k-means is hard clustering or centroid based clustering, and centroid based clustering. Okay, let's see what are these things. Centroid based clustering, when we have centroids. Okay, and according to the distance from the centroid, we will place the data point. Okay, means this data point, the distance will be calculated. Like if I'm talking about this data point, I'll calculate the distance of this data point from this centroid, from this centroid, from this centroid, sorry, and from this centroid. Okay, and wherever it found that there is less distance, I'll place that data point into that particular cluster. Okay, so this is how you do the placement. You will say that this data point belongs to cluster ID purple. Okay, let's suppose its name is purple, cluster ID purple. Okay, so this data point belongs to my cluster ID purple. Okay, in density based, we see here we have calculated distance. We will see how we can calculate distance here. What are the different methods, and then we will implement this. Okay, example here is k-means. Another is density based. So what we do over here, we don't find the distance. Basically, we just check that where is the more density. And wherever you find more density, you create an outlier over there. Okay, an outline over there, and you say that this is my cluster. And wherever you find when you find density at some other place, you just create an outline over there and you say this is my another cluster. So there will be some points, some data points which never fall in any density. Okay, so this you can say one of the disadvantage, because now you cannot tell about this feature. Okay, about this data row, you won't be able to say anything because this does not belong to any of the cluster. Another is distribution based, means how far your data is present from the from your main means how your data is distributed. Okay, so if you will see about the outer one, okay, you can tell from the distance that how basically how this data point means how if it is placed very far away. Okay, you can say that it doesn't belong to this cluster and you will have those features only. Okay, means basically distribution you will do, and different layers you will form, and you will tell the belongingness of the data point. Okay, now hierarchical is also the famous one, but you implement this, you use this type of algorithm when you have hierarchical type of data. Okay, like the taxonomy. And at any level you cut off the layer, like if any layer you cut off the layer, still you can define the clusters. Okay, because still you have different levels, you have different categories, you have different hierarchy, so you can define the levels over here. This is also the famous one. Okay, after k-means, if you'll see, hierarchical is the famous one, but this you only use when you have hierarchical type of data. Okay, let's see centroid based clustering in detail. Centroid based clustering's example is k-means. Okay, just let me know if I'm going very fast. Okay, I actually wanted to reach to the k-means theory so that we can see its implementation. Okay, now one of the reason we are using k-means is see, when you implement k-means, okay, you can run it in order of n time. Okay, and when you run another algorithms, another centroid, another clustering algorithm, their running time is order of n square or more than that. Okay, since we can run k-means in order of n time. I don't know how many of you are aware of order of n. I hope you all have studied algorithm before. Algorithm as your subject. There we see the running time and time complexity and space complexity.
Yes, ma'am.
So time complexity of k-means in order of n. Okay, means if you have n data points, it will run in n time. Okay, it will take n time. But if we talk about another algorithm, they have order of n square time. N square or more than that, you'll see. Means if you have n rows in your data set, it will take n square time to execute. So this is one of the reason you can say we are choosing k-means. Okay, now k-means clustering is an unsupervised learning algorithm, because clustering is an unsupervised algorithm. So obviously k-means will be unsupervised algorithm, right? Which groups the unlabeled data set into different clusters. How we do that, we will see it step. Okay. Now here k defines the number of predefined cluster. Okay, means you have to, your algorithm doesn't know about this. You have to tell the algorithm how many clusters you need. If you will say create 3 clusters, it will take your data set and will create 3 clusters. If you will say I need 5 clusters, it will take your data set and create 3 clusters, 5 clusters. Okay, and so on. So K means the number of predefined cluster. User need to tell the algorithm what is the number of cluster they require. After that, this is the same thing which I have just informed you. Now, if you say K equal to 2, there will be 2 clusters, K equal to 3 means 3 clusters. Now, how it do that? Suppose I have these data points. I have placed all the data point onto the graph. Okay. And if I apply K means and I'll say K value is 3. So what it will do, it will cluster these data point into 3 clusters. So three groups will be created. Okay. Now let's see its steps. The first step is to cluster data into K cluster. K means follow the following step. First step is select the number K to decide the number of cluster. Means you have data set. Okay, so you will tell that how many cluster you require. So let's suppose I say 2 cluster. So K value will be 2. First thing we have done, I have said that I want 2 cluster. So K value will be 2. Another thing, select random K points on centroids. Okay, means if let's suppose I have data set and I have said I want 2 clusters, so 2 cluster will be found. But every cluster have centroid. If you remember this figure, see this is my cluster. This red one is my cluster, and this cluster have a centroid. Okay, this is also a cluster, and this cluster contains a centroid. This is also a cluster. This cluster contains a centroid. Here also, this cluster contains a centroid. So if I say there are 4 clusters, and every cluster contains a centroid. Now, so always the centroid value will be equal to this number of cluster, right? Now, how you will choose the centroid? So there are 2 methods. Okay. One is select the centroid from your data set. Okay, means inside your data set, you will have several rows, several data points. Choose any row as your centroid. Okay, like if you are saying that there will be 2 clusters, so you will have to choose 2 rows as your centroid, any 2 rows. Okay, this is first method. Second method is choose any data point outside your data set. Okay, means you have placed any point and you have said that this is my centroid, not from your data set, any point you have selected and you are saying that this is my centroid. Both the ways you can do. Okay, after that, assign each data point to their closest centroid. Okay, means in your data set, don't worry, we will see them as well if these points are confusing for you. Okay, but try to understand what are the steps we have to follow. So we have several rows in our data set. Okay, 2 rows we have selected as our centroid. Okay, remaining rows we have to place in clusters, right? So what we will do, we will check the distance of those data points from the centroid. Okay, from both the centroid. Suppose I have checked it with the centroid 1. Okay, let's suppose it gives me that the distance is 5. Then I have checked with the another centroid, and let's suppose it gives me the distance 2. 2 is less. So what we will do, we will say that this data row will belong to my centroid 2, cluster 2. Okay. So we will calculate the distance. We will see how we calculate the distance in what is the method we use to find out the distance in k-means. Okay. So there will be around 3 methods. We will see that. Now it is saying calculate the variance and place a new centroid of each cluster. Now after you have placed all the data points to with their respective centroids. After calculating the distance with every row, you have placed these data points with those centroids. Okay. Now what you have to do, the two groups which are created now. First of all, calculate the mean of the first group. Okay. Whatever is the mean, take that mean as a new centroid. Then let's do the same thing with the another group. Okay. Take out the mean and consider that mean as a new centroid. So we have now two new centroids. Two new centroids we have. Now what you have to do, after having the new centroids, calculate the distance of each row present in your data set with those new centroids. Whichever is smaller, place those rows, place those data point with the new centroids. Okay. Now, what will happen? Suppose two groups were created earlier. One contained 1, 3, 9, and 2. Okay, it contained 1, 3, 9, 2 row, and it contained 4, 5, and 7. Okay. So let's suppose I had only this I had only 7 rows in my data set, and 1392 belongs to my cluster ID 1 and 457 belongs to my cluster ID 2. Okay. Now what I have done, I have calculated the mean. I have find out the new centroid for this and new centroid for this. And with the new centroid, I have calculated the distance of every row again. Now there are chances which the rows which were earlier belonging to my cluster ID 1 now belong to cluster ID 2, and there are chances which belong to cluster ID 2 now belongs to cluster ID 1. Let's suppose like 1, 3, 2 are still here, but this 9 came here. 9, 4, okay, 5, 7. Means my cluster, whatever the value it was holding earlier, now changed. If there is any replacement, if there is any, you can say reassignment of these points, then what we will do, again we will find new centroid using the same method, and we will calculate the distance of every row with the new centroid. Okay. If there is no assignment, okay, even if it is going from C1 to C2 or C2 to C1, any reassignment, we will find the new centroid and we will find the distance again. But if there is no reassignment, we will stop our process. Okay, so see here what we are doing. In the fifth step, we are repeating the third step, which means we are reassigning each data point to the new closest centroid of the each cluster. And when if there is any reassignment, we are going to step 4. Means we are again calculating the distance, we are again calculating the new centroid, and we are placing the rows there. Okay. And whenever reassignment stops, means whenever the rows which were, let's suppose in the next chance, if I have checked that 132 remains here only. Okay. And 9, 4, 5, 7. Okay. These oh. 7 I'm writing. Okay. Now these rows belong to the same cluster. There is no reassignment. Then we will stop our process and we will say, okay, now these are our final clusters. Okay. Now we will see it numerically. I hope at least to get us some idea about this. We will see the numerical. I hope maybe at that time it will be more clearer to you. Let's see it visually and then we will see its numerical. Okay. Basically what we are doing, we will start our algorithm. We will say that we want k number of cluster. Okay, let's suppose we are saying 2. Then we will choose centroid either from the data set or outside the data set or from outside the data set. Then we will calculate the distance of every row with those centroid. Okay, and we will group them together. Okay, based on the minimum distance. Now, if there is any reassignment, then we will repeat this process. And if there is no reassignment, we will end our process. We will say, now these are our final clusters. Okay, let's see this numerically. I'm just skipping this visual representation. I hope it will be more clearer when you will see a numerical. Okay. If you have any doubt till now, please ask, then I'll discuss this numerical. Any doubt, anyone?
No, ma'am.
Okay, let's see the numerical. You will maybe then you will start liking clustering. Okay, why is this happening? Let me just unshare this once. So we have this data set. Okay, we want to apply k-means clustering over here. So first step is we have to tell how many number of clusters we require. So we are saying that we want 2 cluster. K value is 2. Okay, this is our data set where I have this where I have 3 rows, this individual, variable 1, variable 2. Okay, so first I have defined that I need 2 clusters. So these data points will be grouped in 2 clusters. Okay, this is just serial number. The first one is just a serial number. Okay, so these values will be grouped into 2 clusters. Now, this row should go in cluster 1 or cluster 2. This row should go in cluster 1 or cluster 2. Cluster 2. How we will decide that? Okay, so the first thing you have to tell which one will be the centroid. Okay, since we are saying 2 cluster means 2 centroid. Now, there are 2 options. Either you can choose centroid from the data set or from outside the data set. Okay, in this method, we are using from the data set itself. Okay. So we are selecting this row as our centroid and this row as our centroid. 2 cluster, 2 centroid. So this is my centroid 1, 1 and this is another centroid 5, 7. Okay, so 2 groups are created, centroid 1, centroid 2. Next step is find out the distance. Now, to find out the distance, there are 3 methods. Let's come to the distance, then we will come back here again. Now, to calculate the distance, there are basically 3 methods. Okay, I have mentioned only 2, Euclidean, Manhattan, and there is one Minkowski. Okay, Minkowski or something like that. Okay, so using Minkowski, you can find out Euclidean distance as well and Manhattan. Okay, if you want, you can just Google it and you can see the formula. They're just a power change, and by just changing the power, you can find out the Euclidean and you can find out the Manhattan. Okay, now what is Euclidean distance? I'm just expecting that everyone knows how to calculate Euclidean distance, but I'm just revising if anyone forget about this. Euclidean distance, suppose I have 2 points. A point which contain and coordinates are P1, P2. B point Q1, Q2. If I want to find out the Euclidean distance between A and B, so the formula will be P1 minus Q1 whole square plus P2 minus Q2 whole square. And this 1 by 2 means square root I'm talking about. Square root of, if I'll remove this 1 by 2, no? So it will be basically square root, means square root of P1 minus Q1 whole square plus P2 minus Q2 whole square. Okay, this is how you calculate Euclidean distance. Okay, so this is one of the method to find out the distance. Okay, another method is Manhattan distance. Okay, so if I want to find out the difference between distance between A and B, here I do not have any square or square root. It will be just mod of P1 minus Q1 plus mod of P2 minus Q2. Okay, so in our numerical, I have solved it using Euclidean distance. Okay, just take a picture of this formula because now you are going to use it. Okay, if you don't know how to calculate Euclidean distance, just take a picture of it because now you are going to solve a numerical based on that. Done. Another one is, the third one is Minkowski, something like that, Minkowski. Okay. You can just search about it. You can see its formula. Okay. Done. Okay, let's come back to the numerical again. So we have done till step 2 or 3, that we have selected the centroid, and now we need to find out the distance. Okay, this is my centroid. Now what I'll do, I'll find out the distance of this row with this centroid and with this centroid. Okay, and how? Using Euclidean distance method. Okay, after that, I'll find out the distance of this row with centroid 1 and centroid 2. Then another row, then another, and so on. Okay, see, my first row is 1.5 comma 2. I have to find out the distance from 1 comma 1 and 5 comma 7. See how I'll do that. 1 comma 1 point I have. Okay, I'm calculating the distance from 1.5 comma 2. So how? This 1 minus 1.5 whole square plus 1 minus 2 whole square and square root of the whole thing. I'm getting a distance 1.1. So this I have calculated from centroid 1. Okay, now I'm calculating the distance of the same row with centroid 2. I'm getting 6.10. Which one is smaller? Which one is smaller?
1.12.
1.12. So what I'll do, I'll place that row with my cluster 1, centroid 1, right? Then I'll find out the distance of my next row, 3 comma 4, with 1 comma 1 and 5 comma 7. Then 3.5 comma 5 with 1 comma 1 and 5 comma 7. 4.5 comma 5 with 1.1 and 5 comma 7. 3.5 comma 4.5 with 1 comma 1 and 5 comma 7. Okay, all the distance I'll calculate, and finally I'll get that row number 1 to 3 belong to centroid 1 and row number 4, 5, 6, 7 belong to my cluster 2, centroid 2. Okay, next step is I'll calculate the mean of this. I will calculate the mean of these point. Okay, and I will and that will become my new centroid. Here also I'll find out the mean, and that will become my new centroid. How you are going to find out the mean? Okay, I'm talking about row 1. What is the data in your row 1? It is 1 comma 1, right? So variable 1 contains 1 and variable 2 contains 1. Another is what are the rows it contain? 1, 2, 3, na? Okay, 1 comma 1 I have, 1.5 comma 2, 3.0 comma 4.0, means 1, 1.5, 3 contain in variable 1. 1, 1.5, 3. Just take a note of it. 1, or if you want, you can take a picture. Let me just delete this images. Okay. Just take a picture of this data set. Okay, I hope now you can take the picture. Okay, now see, 1, 2, 3 belongs to my cluster 1, right? And what we'll do, first we'll write variable 1 value. Variable 1 contain 1, 1.53, right? We'll take a mean of it. Since we have 3 value, we'll divide it by 3. Then we will find out the mean for variable 2, right? It contains the value 1, 2, and 4. We'll take a mean 3. Now, final value what we get from here, 1.83 comma 2.3. If you'll calculate the mean, these are the values you will get, right? So this is my new centroid. Okay, one and I'm writing. And this will be my C. This I'm calculating for my another cluster, 4, 5, 6, 7. Just check the value over here. These will be the value in variable 1. These will be the values in variable 2. And this will be your new centroid. 2 and I'm writing. Okay. So clear? Now these are new centroids. If you have new centroid, now again you will calculate the distance of these rows. Okay. With all these rows, you will find out the distance with the new centroids. Okay. And accordingly, you will place the data point. With all the rows, you will find out the distance with new centroid and you will make the groups. Okay. So the new groups, if you will form, it will be like 1, 2 are belonging to one centroid and 3, 4, 5, 6, 7 belongs to group 2. Okay. What does this mean? See, earlier 1, 2, 3 belongs to same group. 1. Sorry. Here you were finding 3, right? But now 3 is being reassigned to the cluster 2. Okay, since there is reassignment, we cannot stop our process. We again need to find a new centroid from here and new centroid from here. And from that new centroid, see, our new centroid will become 1.25, 1.5 and 3.9, 5.1. These will be our new centroid. Now with these new centroid, again you will go to our original data set. You will find out the distance of all these rows with these new data points, new centroids. Okay. And after finding out the distance, there will be groups. Okay. And you will see that there are no reassignment. Okay, 1, 2 belongs to the same group, 3, 4, 5, 6, 7 belongs to the same group. There is no reassignment now. Means you can stop your process now. And you can say these rows will belong to group 1 and these rows will belong to group 2. Okay. Clear, everyone?
Yes, ma'am.
Hmm?
Yes.
Okay. If you find it confusing, you can do one thing. First, do the numerical for this data set. This is a very small data set. Okay, calculate everything for it. And then since this is for k value 2, then try it with k value 3. If you will plot the graph will be like this. And then try it with the k value 3. Okay, or k value 4. Okay. Till here we have discussed. Now, if anyone have any doubt, please ask. No doubt? Okay. So in Monday's session, we will see its implementation and we will see if we do not know that how many cluster we should take. So what are the different methods for it and how we can implement that? Okay. So both those implementation we will see and methods we will see. Okay. So study about this algorithm, and if you face any difficulty, do let me know about this. And if you have doubts right now, you can ask. Okay, Shrikant. Okay, then thank you, everyone. Bye bye. Take care. Let's meet on Monday. And Ashish, I'll tell you about that how means when you can come. Okay.
Yeah, sure.
Okay, Ashish.